Buenos días a todos, bienvenidos a este homenaje al doctor Manuel Sandoval Vallarta. Por favor, le pido a los familiares del doctor que tomen sus lugares en la primera fila aquí del lado izquierdo mío, del lado derecho suyo. Aquí tenemos unos lugares para ustedes. Y a los miembros del presidium que tomen su lugar. Please, all the members of the presidium who are present, please take your seats. Sí, sobra una así. So we are going to start now. So thank you very much and welcome to this tribute to Manuel Sandoval Vallarta ceremony. So I'm going to present the members of the Presidium. First of all, we have Professor Sunil Gupta, representative of the International Advisory Committee of IUPAC. Thank you very much. Then Professor José Valdés Galicia from the Geophysics Institute of UNAM, who is online. Welcome. We have also Dr. Luis Felipe Rodríguez from National College of Mexico. He is also online. Welcome. Let me introduce to Dr. Ibrahim Torres Aguilar, who is representing the Hawk Observatory and the SWGO project. Now we have Dr. Mildred Quintana from the Mexican Physical Society. Thank you for being here, Mildred. Then Dr. José Guillermo Vallarta Plata, who is the grandnephew of Manuel Sandoval Vallarta. Thank you for being here. And we welcome all the family and relatives who are now. Thank you very much for coming. And also, we want to greet our special guests who are Dr. Miriam Mondragon from Institute of Physics, UNAM. Is here, and she just told me that as a child, she met Dr. Sandoval Vallarta. So she has. Then we have Dr. Takaki Kajita. I don't know if he's online yet, but in any case, we will greet him. Then Dr. Representing Linda Medina, the Decan of the Occidental Region of Science Engineering of Technological Institute of Monterrey, we have Dr. Alejandro Katsumi Tomatani Sanchez, who is in representation of the Decan. Then we have Professor Ralph Engel as Vice Chair of the C4 of the IUPAC, is here from the whole conference. Then Professor Karl-Heinz Kamper, representative of the Scientific Program Committee of the IUPAC. Dr. Eduard de la Cruz Burelo, representing Simbestan, one of the main institutions for science in Mexico. Thank you for being here. We have Professor Brian Pattison, who is the editor of the proceedings of the symposium, and then Hari Haran Balakrishna from the Tata Institute of Fundamental Physics, or Fundamental Research in India, so who is a part of the local organizing committee, and of course, Dr. Eduardo, who is the main organizer. Thank you. So let me pass the microphone to Professor Sunil Gupta, who is going to tell some words.
Thank you, Dr. Karen. It's indeed a great honor to be speaking on this occasion, and having met Dr. Vallarta Plata, who is a descendant of the great Mexican scientist, Professor Manuel Sandoval Vallarta, whose 125th birth anniversary we are celebrating during this symposium. May I have the first slide? It's actually a message from Professor Takaki Kajita, Nobel laureate and chair of the IUPAC Commission C4. This is a message from Professor Kajita. The International Symposium on Very High Energy Cosmic Ray Interactions is a biennial conference series that was started in 1980, and the last edition and in-person participation was held in 2018 in Nagoya, Japan. ISWEGRI is quite different from other international conferences in that it has pure participation but provides ample opportunity and time for intense discussions and interaction. Therefore, I am delighted to observe that after 6 years, all of you got the opportunity for face-to-face interaction in Puerto Vallarta. This symposium is awarded by the International Emulsion Chamber Committee and is sponsored by the IUPAC on the recommendation of Commission C4. I take this opportunity to recognize the local organizing committee and its convener, Professor Eduardo de la Fuente, for doing an excellent job of organizing this symposium. I thank the Scientific Program Committee, chaired by Professor Karl-Heinz Kampert, for inviting eminent scientists to cover various important topics and the results from major experiments. Though I had the privilege of serving as a member of the International Advisory Committee of the symposium, but in my capacity as the chair C4, I thank the International Advisory Committee chaired by Professor Gupta for providing leadership for the Isvegri series. Year 2024 is very special because it happens to be the 125th birth anniversary of great Mexican cosmic ray physicist, Professor Manuel Sandoval Vallarta, who had made pioneering contribution to early studies of cosmic rays. Professor Manuel Sandoval Vallarta also played an important role in the growth of Mexican science and its scientific institution. I am especially pleased to learn that the city of Puerto Vallarta is named after his grandfather, Mr. Ignacio Luis Vallarta Oguzon. I would like to convey my best wishes to all our Mexican colleagues on the occasion of 125th anniversary of the birth of Professor Sandoval Vallarta and congratulate the organizers of 22nd Isvegri for hosting a very successful symposium. Thank you. Signed, Takaki Kajita. I would like to add that this symposium could not have been organized at a better venue or at a better time than in 2024. As we all know, Professor Manuel Sandoval Vallarta was not only a great scientist, but he made such phenomenal contributions that it has left a lasting influence through his work on the studies of primary cosmic rays. Professor Sandoval Vallarta studied at the renowned Massachusetts Institute of Technology in the USA and subsequently became a professor there. He collaborated with top scientists of that era, such as Nobel laureate Arthur Compton and Louis Alvarez, among others. And this is something which Professor Samuel Ting, another Nobel laureate, mentioned in his public lecture yesterday. So may I have the next slide? Okay, so as you know, North and South America together cover the largest range of latitudes from north to south, from 85 degrees north to 55 degrees south. And being a scientist with roots in Latin America, Professor Sandoval Vallarta was instrumental in carrying out experiments in South America that helped Compton establish the charged nature of primary cosmic rays, which made Arthur Compton the first scientist probably, or maybe second scientist to feature on the cover of Time magazine in January issue of 1936. So this I found in internet. So it mentions, the importance of cosmic ray science, and this could not have happened without the contribution of Professor Sandoval Vallarta. Professor Sandoval Vallarta also mentored future Nobel laureates such as Richard Feynman, and in the 1940s, he returned back to Mexico and played a pivotal role in the growth of science in Mexico in the post-war era. Because of his towering stature and reputation, Mexico was awarded the 4th International Cosmic Ray Conference. May I have the next slide? 4th International Cosmic Ray Conference, which he organized in Guanajuato, I hope I have pronounced this correctly, in 1955. And in that, he succeeded well before the scientists from many other advanced countries such as USA, Canada, Russia, and Japan. And he was the editor of the proceedings, and these are available online if you want to look at that. It is really fascinating to look at the family tree of Professor Sandoval Vallarta. One of his descendants is here, so may I have the next one? This was located by Hariharan, and as you can see that Professor Manuel Sandoval Vallarta was the grandson of Mr. Ignacio Luis Vallarta Oguzon, who was a extremely distinguished lawyer, professor, and politician who served as the governor of Jalisco and in several other high positions in Mexico. The city of Puerto Vallarta, of course, is named in his honor. Therefore, it's only appropriate that in 2024, on the occasion of 125th birth anniversary of Professor Manuel Sandoval Vallarta, a truly eminent cosmic ray scientist, tributes are being paid to him during this meeting in a field where he himself made such distinguished contributions, and the city, therefore, is also an appropriate venue, being named after his grandfather. So with this, I would like to thank all of you for being present here, and we convey all the best wishes on the occasion of 125th birth anniversary to our Mexican colleagues and to all those present here. Thank you.
So thank you very much, Professor Gupta. So our next speaker is Dr. Jose Valdez Galicia from UNAM, who is online. So could you please allow him to speak? Can you try to speak, Dr. Valdez? Now, we cannot hear you.
Please speak.
Dr. Valdez, anda por ahí.
Can you hear us?
No me escucho. Hello? Now you can speak. Okay. Well, thank you very much.
I'm only sorry that I cannot be present, but I want to thank you for the invitation and speak a little bit about the contributions of Manuel Sandoval Vallarta, mainly to cosmic ray research. Of course, he did other scientific contributions to Mexico, but I think his key contributions were in cosmic ray. So can I have the next slide, please? Well, we all know that this story started with Victor Hess with his balloon flights in 1912 was definitely established the extraterrestrial origin of the cosmic radiation, and the name of cosmic rays is due to Robert Millikan, who in 1926 produced a very beautiful theory, but as many beautiful theories in science was all wrong. Well, anyway, the next slide. So starting the 1930s, there was a debate of what was the nature of cosmic rays. This was already mentioned by Professor Gupta before me. And this controversy was known as the Compton-Millikan controversy. And one of the key experiments, one of the key events that marked the discovery of the nature of cosmic rays was 1932. 7 groups organized by Arthur Compton were at diverse points in the Earth's surface, and they were carrying identical detectors. The expedition, one of the expeditions, included Mexico, and the visit was organized by Manuel Sandoval Vallarta. He was easing the troubles to install detectors in the Nevado de Toluca, who is at 3,000 meters, over 3,000 meters, Mexico City, who is at 2,000 meters, and Veracruz, who is at sea level. So after this expedition was when the latitude curve was established, and I quote the paper because I think it is important. It says, at sea level, intensity at high latitudes is 14% greater than at the equator. At 2,000 meters high, 22% greater, and at 4,360 meters was 33% larger. This variation follows the geomagnetic latitude, and this is very important, closer than the geographic latitude. And it was a paper published in the Physical Review in 1933. So the conclusion was unavoidable. Cosmic rays must be charged particles, setting an end to the Compton-Millikan controversy. And in the next slide, it was where Manuel Sandoval Vallarta enters the game. Together with Georges Lemaitre, the famous cosmologist, they set themselves to study charged particle trajectories in the geomagnetic field. And they produced, which is considered a seminal paper in the cosmic ray field, where the Lemaitre-Vallarta theory was established. And I quote the paper. They say, considering the influence of the geomagnetic field in the trajectories of charged particles, we show that they follow the experimental variations of cosmic radiation with the geomagnetic latitude found by Compton. Cosmic radiation must contain charged particles. For negative particles, there must be a preference of particles arriving from the east, and inversely for positive particles. So this was a paper also published in 1933, but it was suggesting then an experiment. We had to, the community had to prove if the particles were coming from the east or coming from the west to know the nature, if they were positive or negative particles. And in the little draw that I made here is the latitude curve showing that there is a 3-to-1 more or less proportion of the cosmic ray intensity from the equator to roughly 60 degrees latitude, and enhancing the fact that the equator of cosmic rays is not coinciding with the geographic latitude. Well, another thing is that in this paper, it is also shown that the latitudinal variation of the cosmic ray radiation may be attributed to particles of 10 to the 10, so electron volts. So this was the first suggestion that cosmic rays were really particles of very, very high energy. So this was another of the contributions of Manuel Sandoval Vallarta. In the next slide, we see, the idea of performing an experiment was matured, and Sandoval Vallarta and George Lemaitre advised Compton to organize another expedition to Mexico, and this was organized by Compton sending his student Luis Alvarez and Tim Johnson to perform an experiment in the Geneve Hotel in Mexico City. Is in Mexico City downtown. By the way, the hotel exists still, and the idea was very simple: put two Geiger-Müller counters, one on top of the other, and putting coincidence circuit so that the particles can cross and be oriented in different orientations, so to speak, and we can then see in which direction correspond the larger intensity of cosmic rays. So from these experiments, it was concluded that the cosmic ray flux was significantly greater from west direction. Therefore, cosmic rays are predominantly positively charged particles. Later expeditions confirmed this fact, and this is another contribution also of Manuel Sandoval Vallarta, who suggested and facilitated that this important experiment on cosmic rays was performed in Mexico. This sparked other researchers, motivated them to install a cosmic ray meter in Teoloyucan, and the Mexicans who are in the audience will recognize the names of Alfredo Baños, Joaquín Gallo, and Alfredo Baca, who were in charge of this detector. Another cosmic ray detector, a cosmic ray telescope, worked for some time in the MAIS Palace in the Mexico City, and that was in charge of Carlos Greff, another very distinguished physicist, one of the founders of the institutional physics in Mexico. So all these experiments, together with other happenings, give way to the foundations of the Physics Institute of UNAM in 1939, who remains, the most important physics institute in Mexico, and this was as how research in physics started in Mexico. So later on, a little bit after the foundation of the Physics Institute, Manuel Sandoval Vallarta creates there a group to study cosmic ray propagation in the Earth's magnetosphere, and they produced a very important concept, which is the asymptotic direction of cosmic rays. We all know that cosmic rays, when they are observed in the surface of the Earth, they do not come from the direction as if it was a light ray, or the impact point does not coincide as if we didn't have a magnetic field. So the geomagnetic field was used as an analyzer to see how the different particles were behaving, and this concept of the asymptotic direction was crucial and was produced in some papers by George Lemaitre and Manuel Sandoval Vallarta, from which the construction of the asymptotic cones of acceptance, which are drawn, some of them in a little slide on the right, and we see, for instance, that Mexico is not looking at the latitudes where it is place, but is looking at latitudes in the south, and one of the extreme cases is the installation of the cosmic ray station in the South Pole, which is looking north. So the effect of the geomagnetic field of cosmic rays was exhaustively studied by Manuel Sandoval Vallarta, and they produced many papers on that line, making a very substantial contribution to the knowledge of cosmic ray propagation. So, as was already mentioned, the 6th International Cosmic Ray Conference was celebrated in Guanajuato, in Mexico, thanks to Manuel Sandoval Vallarta, and he presided the organizing committee, and this sparked more cosmic ray research in Mexico. So later on, we can see the legacy. Today, we have in Mexico City, in the university campus, a neutron monitor. It was located in a beautiful building. I couldn't resist the temptation. And now we have the first neutron monitor was in this building, and now we have another super neutron monitor working continuously from 1990. So we have 3 solar cycles with continuous operation. We have also a detector in Sierra Negra, where the large millimeter telescope is installed. And this is part of a world network of solar neutron telescopes. There are 7 telescopes around the world. Sierra Negra is at 4,600 meters height. In the next slide, we see another of let's say, the legacy of Sandoval Vallarta, which because in 1996, a group of several institutions in Mexico was formed, and we started participating in the Auger experiment, which is a very successful experiment nowadays. And the group was named after Manuel Sandoval Vallarta. There are other experiments and other contributions in Mexico, like in the next slide, we see another important experiment, which is the Hawk experiment. And we see the next slide, which you certainly all know. And I just want to mention that, again, this is a multiple institution participation in Mexico, and this was in 2007, and the proposal was led by Alberto Carramiñana from INAOE. But of course, there are other experiments, and in the next slide, we just mentioned some of them. Escaramujo, who is in Chiapas, Lago, and we are part of important international collaborations like the CTA or the GMU. We also were capable of organizing another international cosmic ray conference in 2007 in Mérida, and we think all these and other contributions, of course, are part of the legacy of Manuel Sandoval Vallarta. And in the last slide, we just see a stamp of Manuel Sandoval Vallarta and himself talking to Georges Lemaitre, which was his companion for the most important he produced. Well, many thanks for your attention.
Thank you very much, Dr. Valdez. This was a very, very interesting talk. So now we pass the time to Dr. Luis Felipe Rodriguez, who is also online. Can you please try to speak? Can you hear me? Could you please? So maybe we can pass the microphone to the next speaker. Meanwhile, the talk by. So our next speaker is Dr. Ibrahim Torre, who is going.
Thank you. It's a profound honor and privilege to stand here today to pay tribute to one of Mexico's most distinguished scientists, Manuel Sandoval Vallarta. His pioneering work in the field of cosmic rays has left an indelible mark on the scientific community, and it is fitting that we gather here to celebrate his contribution. Vallarta's legacy is not only a testament of his genius, but also a beacon of inspiration for generations of scientists who follow in his footsteps. In the 1930s, he showed beyond any doubt that cosmic rays was composed by charged particles. The only remaining question was whether these particles were positive or negative. To resolve this, Vallarta led an experiment on the roof of the Hotel Genève in Mexico City. Their work demonstrated that the cosmic radiation is primarily composed of positive particles, later identified as protons and other atomic particles. This groundbreaking experiment was a significant milestone in the study of cosmic rays. Today, I am proud to speak about the Hawk Observatory as a testament to Vallarta's legacy. The high-altitude water Cherenkov Hawk is a gamma-ray observatory located in the beautiful Sierra Negra mountain in Puebla, Mexico. It stands as a beacon of scientific excellence and international collaboration. Hawk is an observatory that has a global recognition in no small part due to the foundation laid by Vallarta's work. Hawk is designed to observe high-energy gamma rays with high sensitivity. These gamma rays are most energetic form of light, and their study provides invaluable insights into some of the most violent and energetic processes in the universe, such as supernova, black holes, and neutron star collision. The observatory consists of an array of 300 water tanks, each with sensitive light detectors at the bottom, capable of detecting Cherenkov radiation produced by gamma and cosmic rays events. One of the remarkable aspects of Hawk's operation is its ability to detect 25,000 cosmic rays per second. This incredible capability allows scientists to gather vast amount of data, providing critical insights of the nature of cosmic rays and their interaction. Recent articles from the Hawk collaboration have provided valuable insights on various aspects on the cosmic rays. Hawke has made numerous significant discoveries. It has the ability to detect and study gamma rays from distant astrophysics sources, including supernova remnants, active galactic nuclei, and gamma ray bursts. By observing these high-energy phenomena, Hawke provides critical data to help scientists understand the fundamental process in driving in the universe of the most energetic event. Another notable achievement of Hawke is the contribution to study the dark matter. Dark matter is a mysterious substance that makes up a significant portion of the universe mass, yet it does not emit or absorb light, making it invisible to the traditional telescope. The Hawke has the ability to detect gamma rays, allowing the scientists to search for signals that might indicate the presence of dark matter particles. The Hawke Observatory also plays a big role in the study of gamma ray bursts. The GRBs are extremely energetic explosions that occur in distant galaxies and are among the most powerful events in the universe. The impact of the Hawke discoveries extend beyond the astrophysics field. The observatory's findings have implications for particle physics, cosmology, and fundamental physics. As a curious connection, I would like to share a personal note. I received my PhD in the Institution of Physics in the University of San Luis Potosí, an institution proudly named Manuel Sandoval. I would like to share a fascinating detail also that happened recently. The last Hawke collaboration was held in the Geneva Hotel. You have was part of the history of Manuel Sandoval Vallarta. As we celebrate the achievements of Hawke, it's also my pleasure to announce the next exciting chapter in this journey. Thanks to the successful of Hawke and following the footprint of Manuel Sandoval Vallarta's monumental contribution, we are embarking on a new adventure: the construction of the Southern Wide-Field Gamma Ray Observatory. This new observatory will further expand our capabilities, allowing us to explore the southern hemisphere with even greater precision and depth. SWIGO will be a crucial instrument in our quest to reveal the secrets of the cosmos, continuing the work that Manuel Sandoval Vallarta so brilliantly initiated. SWIGO represents a significant advance in the gamma ray astronomy. It will be located in the south hemisphere, complementing the observations made by Hawke in the north. This strategic location allows for a more comprehensive view of the sky, enabling scientists to study gamma ray sources that are not visible from the north. The design and the technology of SWIGO built on a successful model of Hawke. It will feature a large array of water Cherenkov detectors, enhancing its sensitivity and detection capability. Manuel Sandoval Vallarta legacy lives on remarkable achievements of Hawke Observatory and the promising future of the SWGO SWIGO. His contributions have not only enriched our scientific understanding, but have also inspired a new generation of scientists to pursue their curiosity and passion for discovery. As we honor his memory today, let us remember that the pursuit of knowledge knows no boundary, and that together we can continue to push the frontiers of science just as Vallarta.
Thank you very much, Ibrahim. So now we go to Dr. Luis Felipe Rodriguez. Can you?
Yes, but you have, you have to, activate my audio. Can you hear me now?
Yes, and now you can share your screen.
Okay, I'll share my with this. I hope that you can see it. And I will be talking of another aspect in the life of Manuel Sandoval Vallarta, which is the creation of institutions and also the concern of doing popularization, outreaching the scientific results to the general public. And this is why he was involved in the creation of what is called the National College or El Colegio Nacional. We already heard that Sandoval Vallarta arrived at the MIT in 1917, and he was related with the MIT for almost 30 years. He was first a student and later a professor of theoretical physics. When he arrived at the MIT, the famous MIT dome was just built. It was built 1 year before, so the dome was still fresh. And this picture is from Carl Compton's inauguration as president in 1930. Carl was the brother of Arthur, which Sandoval Vallarta was involved. in the cosmic ray studies, and probably Sandoval Vallarta was in this crowd, but it is impossible to be sure. Carl was a great administrator, and Arthur was a great scientist. So now, always during his summers, Sandoval Vallarta visited Mexico, and he started talking with politicians, with personalities, and trying to convince them that it was necessary to have institutions that would support scientific research. So one of his first successes was in 1943, where a commission for scientific research was created. He was the first president, and this commission has evolved over the years, first to the National Institute of Scientific Research in 1951, later in 1970 to the National Council of Science and Technology, let's say the Mexican equivalent of the National Science Foundation. And this year, everything seems to indicate that CONACYT will suffer another transformation, becoming a state secretary of sciences, humanities, technology, and innovation. And hopefully the budgets will grow with this transformation. Now, what is El Colegio Nacional? It was created also in 1943 by President Manuel Ávila Camacho. Ávila Camacho was a creator of institutions. During his 6 years as president, he created many things. Now, El Colegio Nacional is an academy that has now 40 members, that our main duty is to write articles, to give talks, to write books, and to do outreach in the topics of a specialty. We are not only scientists, we're also artists, humanists, and to some degree, we are sort of like the Mexican version of Le Collège de France, although Le Collège is different in detail. Now, we have a motto, which is freedom to knowledge, and we even have an emblem, which is an eagle taken off above the sun. That is what we will now call a logo. Here it is the Colegio Nacional logo or emblem. Well, so one of the persons that was involved very much in promoting this was Sandoval Vallarta, and he was one of the 15 founding members. And here there is very interesting photograph of the 1943, and in the photograph we immediately recognize Sandoval Vallarta, always so well dressed, so well attired with his hat. But in this group there is a set of really distinguished Mexicans that were involved in many things. Just to name some, here we have the famous muralist Diego Rivera and Jose Clemente Orozco, who were also among those 15 founding members. Now, the El Colegio Nacional immediately started organizing talks for the public, publishing articles, books, doing all sorts of activities. And in this program that I found for 1943, July of 1943, we see the names of these distinguished Mexicans. And at the middle of the table, we have Manuel Sandoval Vallarta with a talk of selected topics on theoretical physics. There were many developments in physics by 1943 that the public and even many scientists in Mexico didn't know about. And Sandoval Vallarta was one of the persons that did a lot of popularizing this knowledge. But we see the other really distinguished Mexicans, writers, cardiologists, archaeologists. So this was a really nice institution. Now, Sandoval Vallarta had a really wide culture, and he must have enjoyed being at El Colegio Nacional because he had the opportunity of communicating with artists, with humanists, with philosophers. He always had this wide culture, and there is this really interesting an anecdote that in 1939, while he was at MIT, he was visited by a young Argentinian physicist, Ernesto Sabato. Well, he published a paper, and at the end of the paper, he says, "I wish to thank Professor M.S. Vallarta for suggesting this problem and for worthwhile discussion." Now, Sabato abandoned physics, but he then became a really excellent writer, one of the best Latin American writers of the 20th century. One of his books, El Túnel, is really great, and if you can, you should read it. But he started as a physicist and working with Sandoval Vallarta. Now, When he was at the El Colegio Nacional, Sandoval Vallarta was able to interact with these persons, in particular with the painter Diego Rivera. Diego Rivera was not only a fantastic muralist, but he also did a lot of portraits. And here we have a picture of Sandoval Vallarta on the left, and on the right, this famous painting of Diego Rivera, the mathematician for which Sandoval Vallarta was the model. And here you can see that he was indeed the model. There's very similar features in both the picture and the photograph. Now, El Colegio Nacional has continued to be doing these things. We try to take advantage of the fact that we have persons from different aspects of life, and we try to do events where we have, for example, writers and scientists. And here is an example, a symposium on eclipses, where we invited Juan Villoro to talk about eclipses in the literature, eclipses in art, and also the scientists talk about eclipses from the scientific point of view. We also publish books, and one of the most interesting books that you should try to find if you really want to know more about Sandoval Vallarta is this book published by Fernando del Rio, and under the El Colegio Nacional. It's a very nice, very complete biography of Sandoval Vallarta. Now, El Colegio, has had many distinguished Mexicans. In particular, the 3 Mexican Nobel Prizes over the years have been members of El Colegio Nacional. Alfonso García Robles, Peace Nobel Prize, Octavio Paz, Literature Nobel Prize, and Mario Molina, Chemistry Nobel Prize. And they were, I did manage to interact with Mario Molina, who has passed away, unfortunately, and we had many great talks with these important persons that represented many branches of intellectual life in Mexico. Well, let me finish just saying that, of course, Sandoval Vallarta not only was involved in the creation of many Mexican institutions. It's unbelievable, by the 1950s, 1960s, he was in every committee, in every council, in every panel in Mexico, and in many in the international frame. I don't know how he did that because, committees take a lot of time on you, but he was able to do that and to continue publishing. Now, in particular, I would like to remind that in 1964, Abdus Salam, the Nobel Prize of Physics, with the support of the government of Italy, of the UNESCO, and also the Atomic Energy Commission, managed to create the famous International Center for Theoretical Physics located in Trieste, Italy. Now, Sandoval Vallarta was the first scientific director of this institution that is so important. It has, received tens of thousands of scientists over the years. And also in Mexico, we have the direct impact that in 2012, the International Center and the Universidad Autónoma de Chiapas created the Mesoamerican Center for Theoretical Physics in Tuxtla Gutiérrez. And in this center, among other people, worked the Dr. Karen Caballero, one of the organizing of these meetings with Eduardo de la Fuente and myself. So the presence of Sandoval Vallarta is really all over the place, and I'm really happy to participate in this ceremony. And thank you very much for the invitation.
Thank you very much, Dr. Luis Felipe, for this very interesting talk. We hope we stay there listening the rest of the words. And now we invite Dr. Mildred Quintana from the Mexican Physical Society.
Thank you very much for this invitation. I am really excited to be here. I am not for this area, but I had the opportunity to know about it first when I was a postdoc. I went to visit the Gran Sasso Lab, and for me, it's by far the most amazing scientific infrastructure that I have seen. I then had the opportunity to collaborate with Miriam Mondragon in a commission in the National Research System in Mexico, and I learned about your work, and that is completely different from other areas in physics. And I'm really amazed about hearing all this about Manuel Sandoval Vallarta. As Ibrahim, I also was working in the Institute of Physics in San Luis Potosí that it had his name, and it is really an honor. And now I would like to talk as a part of the Mexican Physical Society, what we need to do to try to push new generations to be as smart, as hard worker, and as a human being as Manuel Sandoval Vallarta. Please, the next. Okay. Science it's facing a lot of problems because now scientists are not recognized, but the deep problems that they are trying to solve are recognized from the amount of money, that how many papers they publish, then how many friends do they have. And this is very, very bad for science, not just in Mexico, all over the world. And we had many problems. The academy, it doesn't have enough money for funding to do real research that every time is more complex, because the problems that we need to face now are more difficult. Not, I don't mean that in the past were easier, but now are really more complex because we know more things. And the experiments, as we need to publish a lot and we need to do it very fast, and there are really bad designated sometimes. We have problems also with the peer reviewing and many other problems that science is facing all over the world. And in Mexico and developing countries, this is even worse because we don't have the infrastructure, we don't have the money, and this is very dangerous for our community, because then if the new generations, they cannot see what is really to be a science, we will be in really very hard problem. Please, the next one. What are the big problems? Your community is really focused on solving these problems, and this is very, very important to keep going, working hard in this. The problem is what the universities make, what the black holes looks like. What are other universities? It's time traveling possible? And these are the really big question nowadays. And they cannot be solved in an instant manner. They cannot be solved very fast. And we need to be really compromised in keeping doing real science. I'm sorry, I'm talking also for the students that probably are not so many, but it's the future that it's in danger. And for sure, this can be with other problems like the water scarcity, the climate change, that where are we as human beings, that if we can be artificially or genetically modified to solve next problems of humanity. And this can be worked only if we work together as a community. Please, the next one. And in Mexico, we have very nice infrastructure that Ibrahim was showing us before, but we don't have the capacity of Europe or US or Japan or now China. And this is very important because Mexico and developing countries need to push this international collaboration and use these facilities. And for this, Mexico needs institutional support. Our institutions need to breathe again, and we need to support of the new generation and all the scientific community in Mexico. And this is the only way that we have to promote new scientific careers, new researchers as Manuel Sandoval Vallarta. And I was, okay, it's okay. I was, this is from your webpage of your conference, and it is very interesting how many of these fields can share deep learning with other fields. And I would like to mention very fast just two of them, that this is a project where I am collaborating, that is Nanospace, but the European Committee, by the European Society. And in this project, with all the data that is coming from the web and other telescopes, we are trying to solve fundamental questions. That this is also very important because basic science need to continue. Basic science is more important. It's more important because it's long-standing than applied science. Basic science is always ahead of technology. If we don't have basic science, we don't do new technology. And for this reason, it's very important to continue funding and supporting basic science. And this is a very good example. In this case, with all the information, spectroscopy, basically, we're trying to see the carbon nanomaterials in the space. My field is nanomaterials, physical chemistry of materials, of carbon materials and 2D materials. And it is very, very new because in this project are people from many, many different areas working together. And for sure here, your field, the cosmic rays and all the particles is very important because we need to know how these rays interact with matter. And another thing that it is amazing is the aerospace program. I was this June, in a conference of material science in Strasbourg, and one professor invite all the material science researchers to work in the aerospace base, the Chinese one, because they are very interested in developing materials to protect from the cosmic rays. And every time we are closer to many exciting discoveries, I am sure. I'm very excited to live in this time because the future is amazing. New generation probably are a bit depressed, but I am sure that there are many things to do in the future. And in the space, there are many things that we can discover soon. And I'm from solid state, and then this is something very basic that it's very interesting, and it's also very amazing that we have this graphene material that is a 2D material, and it is there are many experiments that are running now. We cannot do this type of experiments in Mexico. We don't have the infrastructure, but they are doing quantum physics, and suddenly can be met with the relativistic theory by the direct equation. When we have the coupling of these electrons start to move really very fast, close to the velocity of light. And all the properties of graphene come from this electron movement. And then finally, I'm sorry, I think one slice is lost, but not a problem. The most important thing is that if we want to have in Mexico and developing countries new scientists as Manuel Sandoval Vallarta, we need to work a lot. I was really pleased to hear the conference yesterday for the Nobel laureate, that he was giving some advices, and this is very important. We need to think again in science, not just in publishing papers, not just in being part of a machine that is producing things without a really background. And for this, we need to Mexico to support science. We are very optimistic in the Mexican Society of Physics because we expect that the new government would support against science, and that our institutions at the Mexican Physical Society, the Mexican Academy of Science, can work again and can support new generations and the well-established scientists as well. Because as Professor Tin told yesterday, we need to work in a team, give recognition to the new generations, but also keep working hard until we can to improve science. And the collaborations, international collaborations, are very important for us. It's the only way that we can really do science at international level. Thank you very much.
Thank you very much, Mildred. So now I will give the microphone to Eduardo de la Fuente. So he's going words, and then we proceed to the discussion.
Okay, well, first of all, thank you very much, Professor Sunil, Professor Engel, Professor Cajita Sensei, to support and sponsor and to bring the iceberg here in Puerto Vallarta. Also, with the time, I understand, in my point of view, that sometimes split the science in pure and applied science maybe it's not work, because with that, we promote that people do not understand what is important of the pure or basic science. So maybe science is knowledge, technology is the application. Without science, we cannot have technology because it's the application. Knowledge, science is knowledge. Technology is application. Therefore, if I want, for me, it's like copy and paste in a test. If I only copy technology, maybe it's copying a test. Maybe I can get the A+ score, but it's not right. I am not doing right way. I am not going to get learning. I am not going to grow. It's the same. So that's why I think, and thank you to Sociedad Mexicana de Física to stay. Indeed, we need to promote and understand that science is fundamental, because with science first and then technology is what a country can grow. Also, in this sense, I think is also very, very important, especially for the younger generation, understand, to know, and to study the fathers of the science in Mexico, the work. Thank you, Professor Luis Felipe Rodriguez, to stay here in this tribute to fathers of the science in Mexico, the father of the radio astronomy and the father of nuclear science, Sandoval Vallarta, both fathers of the science, members of Professor Valdez Galicia, thanks to you for your participation. You also are a promoter of the science, and here we have an example. I would like to thank Institute of Cosmic Ray Research of the University of Tokyo, because one of your students, Professor Galicia, is working in the University of Tokyo in the alpaca experiment, and I hope with this we can strengthen our collaboration with alpaca experiment and also with Hyper-K, where we are trying to do an effort between the private and the public institution, like Tecnológico de Monterrey, the most important private institution in Mexico. So thanks also for participate, stay here, and that we are going to try to work and combine the private and the public, because we need combine private and public. We need to make search and develop in the best way is public and is private. And and that's why, as I say, Ibrahim, thank you for coming as one of the leaders in Hawk Observatory. You are the leader of the site. Work too much doing a lot of management. And you know that we stay time in the observatory working and build power and pioneering observatory. And Karen, thank you very much, because also we have brightest women, and it is good to have more women involved on science. And maybe just us as new generation, we need to continue with the work that the Radiant Mexican science worked before us. We need to continue that tradition. And this is important. And I'm going to finish this participation with a message for the younger generation scientists in the country, and maybe in Latin American as well, because Sandoval Vallarta was also a pioneer in the physics in Latin America, not only in Mexico. So we need to understand what is Colegio Nacional, so importance of Sociedad Mexicana de Física, understand who are the leaders, the science of this country, who started, who supported, because with that, we are going to get the knowledge, because sometimes the young generation say, I'm going to be successful if I do science. Of course. Why? Because we have examples like the Colegio Nacional, the founder members, or the. So in this context, on behalf of the local organizing committee of the International Symposium on Very High Energy and Cosmic Ray Interaction, Licenciado Vallarta Plata, a prominent lawyer in Guadalajara, dealing with the tradition of the Vallarta family. A pleasure for me to give this.
So for finishing the act, we will invite Dr. Vallarta Plata to give some word, please. You can stay there. You you can talk from there.
Thank you very much. Thank you for the invitation. It's a pleasure to be here. Well, I'm going to speak in Spanish. Sorry. Tengo que hablar de el doctor Manuel Sandoval Vallarta. El aspecto humano es muy importante en la formación de un ser humano. Y en este caso de un ser humano que además de ser un extraordinario ser humano, fue un excelente científico. Su abuelo había sido uno de los protagonistas del México del siglo XIX. Peleó contra los franceses en la Guerra de los 3 años. Ayudó a consolidar la República después de la intervención francesa y del Imperio de Maximiliano de Habsburgo. Fue gobernador de su nativo estado Jalisco, ministro y presidente de la Suprema Corte de Justicia de la Nación, secretario de Relaciones Exteriores y secretario de Gobernación de México. Se retiró con éxito a la abogacía y dejó importante obra escrita en la que sobresale el Writ of Habeas Corpus. Don Manuel Sandoval Vallarta era nieto de don Ignacio Luis Vallarta y Ogazón. Sus padres, Pedro Sandoval Gual e Isabel Vallarta León. Nació en la Ciudad de México el 11 de febrero de 1899. Desde joven, Manuel evidencia una especial dedicación para el estudio y eso propició que sus padres le dedicaran especial atención a su educación y a su formación. Sus estudios básicos los hizo con los hermanos maristas, demostrando aptitudes para la música y los idiomas. Ingresó a la Escuela Nacional Preparatoria, que en ese entonces funcionaba en el antiguo Palacio de Minería, ubicado en la calle de San Ildefonso. Su ingreso fue en el año de 1912 a 1916, lo que quiere decir que la época más difícil del periodo revolucionario lo vivió como estudiante. A la familia Vallarta le gustaba mucho narrar una anécdota de don Manuel como estudiante de bachillerato. La Ciudad de México había sido tomada por el ejército, posiblemente como consecuencia del golpe de Estado de Victoriano Huerta y el asesinato del presidente Francisco Madero. Los estudiantes, ajenos al movimiento insurgente, se dirigieron a su escuela con sus mochilas al hombro. Al llegar a la calle de San Ildefonso, un grupo de 4 soldados les marcaron el alto y procedieron a interrogar a Manuel, quien iba junto con sus compañeros. Al grito de ¿quién vive?, Manuel, resuelto, dijo a voz en cuello: estudiantes de San Ildefonso y el futuro de México. Refiere el propio Manuel que los soldados desconcertados les franquearon el paso y solo atinaron a decir: tengan cuidado, que hay refriega. El propio Manuel en sus memorias confiesa: nosotros no perdimos un solo año durante ese periodo. Había veces en que era absolutamente imposible ir a clases, ya que había peligro de muerte en salir a la calle. En cuanto disminuía un poco la crisis y podíamos salir, todos nos presentábamos en la escuela, alumnos, profesores, todo el mundo, como si no hubiera pasado nada. El paso de Manuel Sandoval Vallarta por la preparatoria marcó su vida. 2 excelentes maestros marcaron su vocación: Sotero Prieto, maestro de matemáticas, y Juan Mancilla Ríos, de física. Despertaron en el joven Manuel su pasión por estas 2 materias y por la investigación. Al concluir sus estudios de preparatoria, allá por el año de 1916, Manuel pretendió estudiar en la Universidad de Cambridge, en Inglaterra, motivado porque allá daba clases el afamado físico Sir Joseph Larmor. Sin embargo, la guerra que se libraba en Europa canceló sus planes y encaminó sus pretensiones académicas al famoso MIT, por sus siglas en inglés. Esa decisión lo obligó a tomar los exámenes de admisión. Dejo en palabras de Manuel Sandoval Vallarta esa hermosa época. En agosto de 1917, al no poder ir a Inglaterra y recién salido de la Escuela Nacional Preparatoria, tomé los exámenes de admisión en el MIT. En aquella época no había exámenes de admisión en otras partes. Si quería uno tomarlos, era indispensable ir a Cambridge. Se comprende la actitud de un muchacho de 16 años tomando el examen, sabiendo que si lo reprobaban no tenía otro camino que volver a casa. Tomé los exámenes y, con gran sorpresa mía, resultó que fui aprobado, y fui aprobado en un lugar no malo, en segundo lugar en la clasificación definitiva. Esto indica la excelencia de los programas de estudios que entonces regían en esa escuela. Eso no hubiera sido posible, sigue diciendo Manuel, si los profesores de la Escuela Nacional Preparatoria de esa época no hubieran sido excelentes. Porque los exámenes, todavía tengo algunas copias de ellos, no eran nada fácil. Había exámenes de geometría, de trigonometría, de álgebra, de física, de química,
de inglés. Cuando fui al tablero de anuncios del MIT para ver si mi nombre estaba incluido entre los aprobados, literalmente me temblaban las piernas. Y cuando encontré mi nombre, casi me desmayé. Casi me fui de espaldas. Sigue narrando Manuel Sandoval Vallarta su periplo en el MIT. Entonces, ingresé al MIT como freshman. En 1917 seguí los estudios de los que en los Estados Unidos se llama el bachillerato, hasta 1921, cuando recibí mi grado en ciencias. Algunos de los recuerdos de esa época no me abandonaron nunca. Los exámenes que nos daban cada 2 semanas, alternadamente en ingeniería eléctrica y en química teórica. Los exámenes de ingeniería eléctrica los daba una vez el profesor Pender y otra vez el profesor Adams. A las 9 de la mañana, todos los lunes, teníamos examen. Bien el de ingeniería eléctrica o bien el de química teórica, que lo daba el profesor Noyer. Estos exámenes nos arruinaban completamente el fin de semana. Puedo afirmar sin exagerar que durante más de 2 años no tuve un fin de semana agradable por el temor del examen de lunes a las 9 de la mañana. Todavía lo recuerdo con cierto pavor después que recibí mi primer grado, el de bachiller en ciencias. Continué los estudios para el doctorado también en el MIT, de 1921 a 1924. Uno de los profesores que más recuerdo en esta época y que más influyeron en mí fue el profesor E.B. Wilson, quien a su vez fue discípulo de Gibbs y uno de los que popularizaron el análisis vectorial. De manera que en cierta forma yo soy segunda generación. De Gibbs pasó a Wilson y de Wilson pasó a mí. Manuel Sandoval Vallarta tuvo en su etapa del doctorado en el MIT a excelentes profesores, entre otros Norbert Wiener, creador de la cibernética, a Pierce, a Phillips, Moore, Strick, quienes influyeron en el joven Manuel. En los cursos de intercambio con Harvard, hizo una profunda amistad con Oppenheimer y con Georges Lemaitre. En 1927, Sandoval Vallarta obtuvo una beca para estudiar en la Universidad de Berlín, centro de la física mundial, donde fue alumno de los prestigiados maestros Einstein, Schrödinger, von Laue y Planck. Estudió con Einstein la relatividad, teoría electromagnética con Max Planck, epistemología con Reichenbach y exégesis con von Harnack. Refiere Manuel Sandoval Vallarta que en esa época conoció y se hizo amigo de von Neumann, que gracias a él conoció a varios de los más eminentes físicos de su época, como por ejemplo Wigner. En esa época trató a Peter Debye, profesor de teoría molecular, y a Heisenberg. Según refiere el propio Manuel, esos años fueron, si no los mejores de mi vida. Fue una época de gran estímulo intelectual, una época en la que realmente adquirí los conocimientos principales de la física. La carrera de Manuel Sandoval Vallarta, después de su extraordinaria experiencia en Europa y su estadía como profesor titular en MIT, posibilitaron su consolidación como excelente científico, cuyos logros se han evidenciado en esta importante reunión. Concluyo con la aportación que mi distinguido tío hizo a su natal país, México. Desde 1943 empezó a visitar a la Ciudad de México con la preocupación de elevar el nivel científico de este país, impulsando la creación del Instituto Nacional de la Investigación Científica, que daría lugar a la creación del Consejo Nacional de Ciencia y Tecnología. La preocupación de Manuel Sandoval Vallarta fue la de llamar la atención del gobierno mexicano hacia la importancia de los problemas científicos, de las aplicaciones de la ciencia y de la técnica al desarrollo económico y social de su país. Muchas gracias.
Thank you very much. With this, we conclude the ceremony.